This evening we have a tree how-to workshop, and we're going to talk about greenhouses. My name is Diane, and our two experts here, Henning and Rob McQueen. So we look forward to hearing more. Thank you.
My name's Henning. I teach part-time at Fanshawe in the Carpentry Techniques program. I'm a licensed carpenter, and I've got a background in fine art. Greenhouses are, I wouldn't say, my everyday building structure, but Rob is here to help with background knowledge on greenhouses specifically. So today we will be building a greenhouse out of PVC pipe and 1x3 spruce. And then it will be sheathed with 4mm poly. You can use 4mm or 6mm poly.
Or 2 layers of 4mm if you wish, because if you put one layer on, as I've discovered, you put one layer on and you get condensation. If you put 2 layers on, you don't get condensation. So you're just as well using 2 layers of 4mm.
I'll teach you some basic carpentry skills, how to cut, how to drill. We'll use hand tools. If you're interested, we can go other and use power tools, and I'll get safety glasses and that kind of thing. And there will be some common carpentry techniques, like how to make something square. If you have a rectangle, it can easily become a parallelogram, and we'll show you how to measure diagonally across both diagonals to make sure all 4 corners are right angles.
I guess we should say that we prefabbed this before. We've already built it, and so it'll go up a lot easier, but we'll explain each part and see if we'll do it from the beginning to the end. We had to figure out which way is the best to do it, how the best to do it. As Graham was saying, we used 1/2 inch PVC. You could also use 3/4 inch, and that would either make it strain bigger or a little stronger. So that's another option you can decide on for yourselves.
The base of our greenhouse is going to be 8 feet by 8 feet square, and it's going to go up in an arc to about 7 feet at the maximum height. So we have here 1/2 inch PVC pipe, okay? So when they say 1/2 inch PVC pipe, it's the diameter on the inside of the pipe. This is an electrical conduit pipe. It actually has a sun resistant rating, okay? It's got 1 belled end and 1 normal end, okay? So they can fit together as many as you want. This is 10 feet long, and it was $5 for 1 pipe. We're going to use 10 pieces, and we're going to cut 5 of them. You could cut all 10 if you wanted, but we decided it would be easy just to make 5 cuts. The total length of each rib will be 2 feet off, 18 feet long.
The reason that we took the 2 feet off was because it was too tall, and it would have weakened the structure. And so we shortened it, and so that it make the structure stronger. The other reason is that because with a snow load, you don't need the extra height anyways. It would be area that you wouldn't be growing anyways, and the heat would go up higher, and for several reasons. More for stability that we cut the length 2 feet.
So if you wanted to keep the longer length, then you might want to make a larger base frame and spread it out. We decided that we wanted about 7 feet in the middle, so that the average person can walk down the middle. So you can, customize it to your own needs. You may want to take only 1 pipe, and you could make a low ground structure that you would have to either crawl in or lift up, right? So with 5 ribs, and you could make it with as many ribs as you wanted, as many lengths as you wanted, right?
Yeah. Turn it into a cold frame.
Yeah, or maybe make 2 side by side so it makes it easy to lift up and down. And I just wanted to mention or add on to what Rob had said about keeping the plants close to the ground. That's where the heat is in the winter. The heat is coming from the ground. Okay, so I'll cut this one. So this is a normal combination saw, hand saw. It's new, so it's quite sharp. You know, every relative probably has an old hand saw kicking around in their shed, but it's probably not sharp. You're going to have to put in a lot of effort. If you want to take it to ETK on Bridges Street and get it sharpened, that would be wise. Or the new blade is quite sharp, and you can feel how sharp it is. You could have a dull blade next to you and then feel this one as well. I could bring another saw out, and you could just feel. That's just going to make it easy for you while you're sawing. Okay, so you want something sturdy to saw on. Feel free to ask questions while I'm going, because you know there's lots of complicated pieces and parts. I'm going to support it as close to the cut as possible, and you might want to do a little back cut to get started. There's no harm in clamping this to the bench. You may need a special clamp to hold a rounded pipe rather than a flat one. Had a long day, so I think I'm a little tired and weak. So that's how you make your cuts easy enough. Sharp tool. You could use a power saw, a chop saw, or a skill saw, or you can actually use a pipe cutter too, which is a plumbing device that goes round and round, and you continue to tighten it. It's got a little cutter wheel on it. Anyway, I'm probably getting too detailed. So you make your ribs, and we decided to use 5 ribs at 2-foot centers. So we've got an end rib, and then we've got 2 other middle ribs. So at 2 feet, you realize that the plastic between that was going to be strong enough to hold snow. Okay? There's no harm in doing another rib in the middle or at shorter intervals, right? 16-inch centers is a common interval for carpentry. One thing to note is that to quickly make use of this 8-foot piece, we've just inset the first and the last rib. So the spacing between this rib and this rib is not exactly 2 feet. It's a little bit less. And we did that just to prevent cracking at the edge. Depending on how much math and time you want to spend, you could inset 1 inch on both ends and then divide by 4 spaces and then get exactly even spacing. It would be less than 2 feet, but harder to work on your measuring tape. Okay, so we didn't feel like this was not fine cabinetry, so we were just to compromise or an allowance for a quick and easy method. Okay.
So that's the back side,
yep.
So we'll put that back there.
Okay.
And then from here, drill the holes,
yep.
as Graham said. And then the next process is to put them in the holes.
So remember that the inside diameter of that pipe is 1/2 inch. The outside diameter is 7/8. So we used a 7/8 spade bit to drill these holes. We should probably show that on the video too. We'll engage the motor fully without stopping until it hurts your wrist, whatever. If you turn, this is called the clutch. If you turn the clutch to 1 to 20, those have different release points at different torques. Or sorry, it will release at different torques. So as you're drilling, if the drill encounters a higher need for power, it will disengage it at those different settings. So 20 being the highest, and 1 being like for fine cabinetry with, say, a brass screw. You don't want to strip the screw. As soon as that brass screw finds its home or a certain resistance, the drill cuts out. There's 1 and 2 speed on the drill. That's just speed. Lower speed has more torque. That's like a phenomenon of motors. There's reverse and forward on the drill. My drill is a battery operated drill. It's got a battery life indicator. I can talk for a long time about amps and volts and brushless motors and things. So I had the clutch and the chuck. So to get the bit in, it releases the chuck, and it's got 3 pinch points that pinch the bit. So I've got it on that clutch, so that's why you hear that sound. If I put it to the drill setting, it'll just keep going until it burns my hand, basically. I've also got a quick release adapter on the front of my drill, so then any hex bit, 1/4 inch hex bit, is quickly changeable. Okay, it's the shape of the interchangeable hex bit. So, 7/8 spade bit. There's other types of 7/8 bits that you can use. If you're drilling, this has a handy space between, it supports on both sides. Show you a few quick marking techniques. So if I want to go in the middle, obviously I just divide my 2 3/8 in half, 1 3/16. And we wanted to have all of our holes in the center of the 1x3 spruce. So there's a few different techniques for making a parallel line along the side. One is I can grip my tape measure, pinch my pen against the end of the tape, and I can run a straight line all the way through. And then I can mark my increments. If I'm doing 24-inch centers or 12-inch centers or whatever, and then I can make my drill at my crosshairs. Slow, steady power. Sometimes it builds up. Remove some of the wood chips that prevent the cutter from activating. A little rotating motion if it's not a fine carpentry project. Now, the point of my drill is going to come through the other side. That can be a handy technique if you want to flip it and then drill from the other side. What that prevents is your drill catching at the end and torquing your wrist or twisting your wrist. So if I keep going through, sometimes it releases too quickly or it catches on an angle and it can twist my wrist. So I also know that when it's going to move, when it's going to catch, it's going to move this way. So I can also put my leg or my body on this side of the drill so that when it bumps or hits against my body and doesn't hurt my wrist. Okay? So anyway, that technique from going from behind helps to prevent some of that twisting, torquing, and uncontrolled drill movement. Okay? So, what do we do then, Rob?
We got to re-drill these.
Okay.
Because of moisture.
You want to make sure the screws aren't in the way there? Here. Now, we want to have two pieces of spruce on each end with holes drilled, and we want to have 5 ribs laid out with each rib inserted into the spruce flush to the bottom side of the spruce. Okay, and so that's what we'll do now. Robbie.
So we'll need screws for this.
So before we put together the end pieces of spruce and the 5 ribs, so in effect we're going to have a piece of spruce on each end, and then we're going to, all together with the 5 pieces, we're going to raise them all together at the same time. But we also want to have a wooden cross rib, a piece going across all of the ribs in the center and on each side of the greenhouse. So we're going to quickly show you how to mark all of those pieces so that all of your spacings as it goes across those ribs can be lined up and stay even. You'll look professional.
One of the reasons for the cross ribbing is so that when the snow comes down and the sitting on it, it won't push it apart. It holds it all together.
So I think I was in the process of making these cross ribs. There was one here. We cut one. These ones with the holes are the two end pieces. Okay? And then I'm going to have a middle rib, or a middle cross rib, and two side cross ribs. So I can just put a line all the way across all of these. So you can use a speed square or a framing square, and you can make a line all the way across all of these pieces. And when you go to install your greenhouse, your PVC pipe is going to be right in between these two marks. Okay. As you can see, I'm lining the marks up with the outside circumference of the drilled hole. And it's not cabinetry, so don't get too hung up on exact precision. It's going to work out relatively well. Now, if you can see, I cut these two pieces to be flush with the outside of the PVC rib on both ends. And I'm going to do the same, this middle cross rib that hasn't been cut yet. And that'll be a good demonstration to cut the wood with the handsaw as well. So, in effect, the three cross ribs are shorter than the end ribs. And the reason that we decided to do that was as the cross rib meets the rib, we didn't want it to protrude outside of the end rib in preventing our plastic from laying flat. Okay? We would have to puncture our plastic around this piece, because what we had done to prevent cracking the end cross pieces is inset the first rib. We didn't want to go too close to the end of the hole or the end of the board to prevent cracking. So you'll see in the finished product, the two end cross pieces will extend past the greenhouse, but the three middle cross ribs will be flush with the PVC. Okay, and that may be confusing at this time, but when you see it together, you'll realize what we did there, okay? We cut our PVC already. Now we can cut our... I would recommend wearing steel toes too. These are not construction shoes. Don't show this to WSIB. The thing with sawing lumber with a handsaw, people often get stuck halfway in. They can't go. And some of the reasons are, one, you're trying to put too much pressure on the teeth. Okay, back and forth and let the teeth do the cutting with the light pressure. Another thing is that their angle, they try to angle. You don't notice a slight angle, but you are angling it if it's binding. If it's getting tight within the kerf, the groove of the cut. So what I would suggest is try to feel for the saw movement not binding, and that'll provide a easier cutting operation, okay? You want to try to turn your arm into a bit of a robot machine and make it go nice and smooth. It's symmetrical, but as you can see, it's not. That's okay, as long as all of the spacings are the same. So we just need to cut that, both these two. try this, eh?
You're doing so good.
Okay, so hopefully these all line up. So now we can go and insert all of our pipes into the end pieces.
I'll get these out of the way.
Yeah. Flush to the bottom side. Okay. Drill. So the PVC is soft enough to take the screw without a pilot hole. Towards the end of the piece of spruce, you may want to do a pilot hole. Okay, but as you get to the middle, generally it's going to be stronger and you don't have to make a pilot hole. Okay, so this is a pilot drill bit. It's got a bigger portion for the head of the drill bit, or the head of the screw, and a smaller portion for the length of the screw. So if I just use this scrap, I'll show you what I mean by making a pilot. Okay. And so if the wood is wet, you don't need to do it usually. If it's drier, or like I say, towards the end of the piece, then you may want to do it. And feel free to pilot all the holes. As long as the end drill bit is not bigger than the maximum diameter on your screw. And if you want me to go into more details about that, I can show you on the whiteboard. Maximum diameter is the biggest part of the screw thread, and the minimum diameter would be structural part of the screw. Okay? So you want it to be around the size of the minimum diameter. And I can do a bigger diagram on the board, and I can define the different parts of the screw too if you want. Am I going too fast, speaking too quickly, or no? Okay. Let me know. Shoot questions if you have any. So I'll just okay, and we already installed this, so we've got most of the screws in place. Now this is kind of similar to the sawing action, where you want to make it nice and straight through the cut, keep your arm machine-like. You want to make sure that your drill is in line with your screw. Oftentimes you'll be skipping, and most often the reason is that your screw and your drill are on an angle, like this, or like that, okay? So what you want to do is make sure that you're nice and straight in line with the screw, and that's going to give you best connection between the bit and the screw. Rob's already on his way to the back, and we're going to do the same thing back there.
Those two end pieces are about 8 feet long, is that?
8 feet, exactly, yeah. So we've tried to use a material and a dimension that is quick and easy with as few cuts as possible. We did cut the middle cross ribs, but all of the base pieces that we're going to use are 8 feet. We didn't have to make any cuts. Both ends are going to want to be under tension, and they're going to want to spring to straight. So we pounded a couple stakes in the front just to push the rail against, okay? So you want to wear safety glasses for this kind of stuff, just in case. Okay. It could have been after we erected the structure and then set it back down, took on some of the curve, and now it's a little bit bowed. When I purchased these, they were all nice and straight, and the supplier, you shouldn't have too much of a problem. So, like with spacing out the ribs going into the end pieces, we're going to space out the cross ribs and lay those out. So we're going to take our total length of the PVC rib. I'll have to measure it just for precision. I think we said 18 feet roughly, so it should be 9 feet. 214. 214 and half is 108. Or 107, I'm sorry. On the first rib and the last rib, and put the cross rib in line with both marks, then I don't really have to measure the middle ribs. Now I'm going to divide that into half again. So basically the whole thing into quarters and make a mark. So 107 and half is 53 and a half. So 53 and a half from both ends. Okay. Explaining the reason why we cut the cross ribs, the 3 cross ribs in the middle, and we did not cut the end base pieces. So right now, when I go to line this up, I'm gonna have it flush with the PVC, so that when my plastic is installed, it doesn't have a piece of 1x3 protruding through the plastic. Okay. Work better. There is a difference between screws. If you buy cheaper screws, less likely to fit on the head of your drill, and the threading may not be as well machined. And a higher end screw often will have almost like a drill bit tip, where it's got a cutting action. So if you can splurge a little bit, I would recommend on the screws. It'll make your fasteners. It'll make your life easier. Cabinet mark is a good place for higher end screws. Lori's Fasteners is an awesome place for hardware. You have to remember to do your math on your thicknesses of your material as well. So we've got 7/8 PVC, and this is called 1x3 spruce, but the actual thickness is 5/8. They're always trying to minimize the amount of product they're giving you, even though they're calling it 1x3 or 2x4. They're shrinking the actual material down and down and down. So 5/8 plus 7/8, 1.5. So I'm using 1.25 screw so that it ensures that it doesn't come out the other side. So leave a 1/4 or an 1/8. This is a pretty big moment, so get ready. Put that one screw in. got it? So now you can see it's a little bit wobbly in many directions, so you might need a hand holding. But we're going to solidify that with some cross bracing.
So I'll start with one screw in here so that
Yeah.
we can square it up.
Yeah. And these pieces at the ends are uncut 1x3 spruce. First squaring procedure. It's a little wily, as you can see.
We haven't tamed it yet.
Yeah. And those stakes come in handy.
That takes one person's job.
Yeah. The first aspect of squaring something is going to be for the base. Okay? We've got 4 sides that are 8 feet long, and they look generally square, that is to say right angles in each corner, but we're going to measure to ensure it. Okay? Good. So to square something, to make sure that it's all right angles in all 4 corners, all you do is measure diagonally and just try to do it as accurately as possible. You can see how Rob's bumping the tape measure into the corner, and then as long as he does that consistently on the second diagonal, then you're fine. Consistency is your friend. You just want to do it the same way, however you did it the first time. And just measure as accurately as possible. 129.5. 127.75. Okay, so we're short in this direction. So I'm going to subtract those 2 numbers, and I'm going to get 1 3/4. To move that into the right position, I divide that 1 3/4 in half. Okay, so I get half plus 3/8, 7/8. 7/8 plus 7/8 is 1 3/4. So what I want to do is I want to move one side 7/8. And this is the short corner, so I'm going to pull it out. I'll just double check that I'm at 128 5/8 on this side. Make sure my math is correct. And yeah. Now, make sure you keep an eye on it and it doesn't move. So the best way to keep something square is to stake it in this situation, or to put a diagonal. So if I put a rigid diagonal, and this can be just temporary, that piece of wood can neither push or pull, so it remains square. If I was to use a rope, I would have to use a rope in 2 diagonal directions, crossing one another, or in opposite diagonal directions, because they're only under tension. There's no compression strength with rope. And you'll see that for lightweight economy, we're going to use twine cross bracing for the rest of the structure. So you can either stake this into the ground, or you can use some cross bracing. The stronger the cross bracing, the closer to the total diagonal. So squaring principle would be strongest if that cross brace was corner to corner. And as you move it to a shallower or a shorter diagonal, it becomes weaker, but it can still provide same strength. Now we're going to put on an end cross member, and after that we're going to diagonal this side, and the back. Ideally we would cross member all 4 sides, but we're going to make a doorway on one end. Okay, so that limits us in terms of the structure, but having a cross brace on 3 sides is going to be our best alternative. Okay, I'll hold it. Yeah. Here. If your lumber is wet, then it might not need it. If it's really dry, definitely needs it. You can go with a longer screw now. I would max out at 2 inches.
I should point out too that we cut them on an angle. We put it in place and then we realized where we had to cut it, then we cut it.
We
It has
simply
already been cut.
put it in place and traced the angle required.
That was a 8-foot long piece.
That was, yeah. Yeah.
The other thing is these that we're inside so that it's out of the way of the ribbing,
Right.
so that he can screw freely into here.
We probably could make it work if we wanted to go flush with the outside, but I guess we realized we didn't need to.
You're not going to lose any room for your planting anyways.
And your plastic will compensate. If you leave the head out a little bit and it's dry wood, it will be less likely to crack. If you want to make that drill, that head flush, then you're more likely to need a pilot bit. Okay, now we're going to install some more of the panhead screws, but we're going to only install them to 1/2 or 3/4 of the distance, leaving the head exposed. And that's going to be able to catch our twine or our rope, which we're going to use as our cross bracing. I'm just putting it in on an angle so that I can catch multiple directions of cross bracing twine. But as long as you wrap it tight, give it a couple rounds, it doesn't really matter the orientation as long as it's not in your other cross members. I'm using the particle head or pan head. It's kind of got a cup shape. It's contrary to kind of a common sense. This one is the flathead. The flathead's got the kind of the arrow pointing into wood, and the particle head or the pan head is the one that stops flush with the top of the wood. Okay, so I'm using the particle head so that it has more grip to catch rope. This one is more likely for the string, twine, or rope to slip off of. Okay. Wobbly, okay, in many directions. The string's going to help a lot. It's not going to be perfect and it's not going to be like steel, but we think it's going to be good enough for wind and snow and rain. But again, this is on a budget, so if you wanted to upgrade, and if anybody wants to talk about upgrading the materials to make something stronger that might cost more, then feel free to ask. We can suggest other materials to. So I'm just going to start in one corner and just common knots. And this is kind of like that little barn drawing that we all do as kids. So at each screw, I'm giving a wrap around the screw head. Okay. Now, you could go and measure these cross distances, these diagonals, to get an exact square, as we had done with the base. Rob and I just eyeballed it. So I said, Rob, does it look good? Does it look good? Okay, so if he said, no, it needs to go more this way, then I would push it over and I would tighten the string. Okay? So maybe just check if it's okay still. Does that look okay?
Centered.
Looks centered. Would Tammy say it's good?
I don't know. I like it.
It's different than the other side. The other side has got to go
That way, yeah. You can customize each plane. The back look okay? Yep. And you want to get these tight. it would be a good method to adjust it actually too. So what's the back looking like?
It's going to have to go your way. So you eyeball it at the back.
Back look good?
Yeah. Pull it this way just a tad.
You want me to tighten this?
Yeah.
To send it that way?
No, tighten it that way.
So I'll loosen it.
Yeah. Much better.
Okay, so see how I loosen this and it shifted that way. Okay. Takes a little bit of thinking to get your brain around that. And obviously, like I said, I figured out a pattern where I didn't have to double any up last time. I'm not going to bother trying to figure that out again. I'm just going to unroll and do another round. Material used before drywall is installed. And it's pretty thick, eh? What would you compare it to?
Sure.
I don't know. 10 times thicker than a plastic bag, like a garbage bag.
This is thicker than a garbage bag.
And this is thicker, yeah.
This is the thickness of a garbage bag. 2 mil would be thickness of a grocery bag.
Yeah. Yeah, that's right.
Yeah.
Yeah. The contractor bags, I think, are 3 mil. The thick black ones.
Yeah.
So you can see it's sturdier. It's not going to move as much. It's still got some flex, but you know it's going to generally stay in position.
The door will help too.
Yeah, and the door
The
will
front
help.
is still open.
Yeah. You could put a vertical piece right here.
That would be good for snow load too.
Yeah.
That piece there.
Yeah. And the door will help on the other side for snow load.
Yeah.
Okay, so what should we do next? Build the door, I guess.
We got to build the sides for the door frame.
Yeah.
So I see one that we have. Here's a hinge side. And I don't see the other one.
So we decided to build the door 2 feet wide. A standard doorway for a bedroom, maybe 30 inches, which is a bit bigger than the 2 foot, but the 2 foot's going to give you a lot of width for growing along the side. So the 2 foot is kind of minimum for the door, and it's maximizing your grow area. On the base, if I've got 8 feet across, I'm going to have 3 feet on both sides. That's going to make 6, and then my 2 foot door in the middle, okay? I'm going to put this around back. Just get it out of the way of the door. As well. 2 3/8, 1 3/16. Yep. Those are height. Well, if it's higher, that's good. We could cut a new piece to fit that kind of exactly. Our previous installation obviously was slightly different, and again, it's not cabinetry work. So we're just
was
gonna.
that an 8 foot long piece too?
That's right.
Was that an 8 foot long piece too?
Yes.
Trimmed down?
Yeah, they were all 8 foot
All 8
long
feet,
pieces.
okay.
Yeah. So do you want to drill that in? So standard residential construction, I would either use a level to plumb this, plumb being vertical, level being horizontal, or I could, in a standard construction, I could usually measure off the wall the same distance from the floor, but we've got the curves here. So I decided to, this is going to be my cross piece, the header for the door. I decided to put a center mark right here for the header. Now I'm going to line that up with the center of my greenhouse, and then I'm going to flush out the end of my piece here. So this is a tad tricky. Now you can put it screws up there. Oh. So just because we installed it before we had this pipe twisted a quarter turn, so Rob just took those screws out and he's going to go straight down.
Center.
You know what? Here, I got another idea. Just to make it easy, let's screw the two uprights together first. and that'll just make it easier for whoever's holding it. We probably did that without thinking the other day.
That centerpiece is 2 feet.
That centerpiece, good question, is 2 feet plus the width of each piece. I've got 2 feet on the inside of that. Okay, so your opening is 2 feet that you're going to be able to walk through. And that's a good point, that your door is actually going to turn out to be 2 feet plus the 2 widths, which was 2 3/8 on both sides. Now, the other thing was we wanted to determine the spacing for the bottom of the door too. So that header can be placed to decide what spacing we want for the bottom of the door. So, sorry to keep going back, and since our door is already built, I'm going to reinstall this header at the top of where I want my door, plus an airspace or however much space I need to clear grass and whatever's on the outside. I don't really want to make my door flush with the ground because it'll rub. So I want to give at least half an inch or an inch. So now thinking about that, we made our door 75 inches. So in this case, I might just use my square to make sure that I've squared this. And notice that I wasn't square to begin with there until I put my square and I wanted to adjust it. I'm going to go into a new hole. If I go into the previous hole, after I've shifted it, it's going to want to tend to slide back into the first hole, continuing to pull it out of square. So I'm just going to choose a new spot, and that's going to pinch it in place. So one screw, and then the piece is connected at my correct height, and I can still rotate it for square, check square. And then install the second screw. So those 2 screws are what's holding this frame square, okay? After we put this up and get it in position, make sure it's parallel top and bottom. We could check the square diagonally with our measuring tape. We could also reinforce with string diagonals on both sides of the door, okay? So now I've got my center on my cross piece. I'm just going to make sure that is center. I've got 28.5 with the 24 plus both width. That is 28.5, 14.25. That is my mark. So I'm just going to eyeball the center of this piece with the center of my mark. So now I could go like this, check my square. There's also other tools, combination square, which I could show you how to use if you want. Which would bump into this. It's an adjustable piece here. But I've made a line on the other side of my center mark, and I can make sure that that is the same. Pretty darn close, so I'm happy with that. Now, since our PVC is in the center of this piece of spruce, and we've put our uprights in line with the PVC, we're going to put the bottom part of the rail in line with the center of this spruce as well. Hold on, Rob, just before you screw that. I've got 23 7/8. So I'll just check that at the top and the bottom. Even though it's not exactly 24, I'm just making sure it's parallel. We've installed these hinges. Remember that your width is 5/8, so you're going to have another screw now. A 5/8 screw would be perfect because then it would just be the thickness of the hinge that is keeping it from coming through the other side. There's a pin in these hinges, and you generally want the head of the pin to be up, right? So that as it opens and closes, the pin doesn't fall out. So I've installed the hinges so that when they're closed flat, they'll be pinched in the inside of the door and the outside of the jamb, this being the jamb. Okay, so again, the squaring, carpenters, I guess, are all about making sure everything's parallel and square. So with our door, we've got 4 pieces. We've got a rectangle, 2 pairs of different length pieces. And I'm going to go outside to outside, 80 1/8. So I was 80 1/8 in one direction and 80 exactly in the other direction. I would take the difference, which is 1/8, divide that in half, and move the door that much. Increment, that small increment, and this type of construction, I'm not going to worry about that precision. We've got a rigid cross piece. And one more trip to get a different size screw. These are number 8 by 1.25 inches. So the number 6 refers to the diameter of a screw. So this number 8 is a thicker screw. So it would be more structural. This would be for finer work. Okay. But I like my cabinet marked screws. They both have a number 2 square, which is Robertson head. So I don't have to change my bit all the time. Okay. I try to buy all my screws with the same head. Oh, I put the screws in here. Okay, so we're just going to leave it right there. So to ensure that everything hangs parallel and straight, I want to make sure that the hinge axle or axis is outside of the jamb. I don't want it to be flush with the jamb. It gives an easier action and motion. There's no binding. If the pivot point is too close to the pieces of lumber, then it's going to bind. So that has to be out. And then the distance from the back to the lumber and the back to the lumber is going to be the same on both of those. Okay? And that's just going to make it so that when it closes, they close flush. Let's see how we did here. That's pretty good. Our header looks a little bit high. Our uprights are lining up nicely. This is the type of project that you stand back and you look at it and you see how things are lining up. Again, if it was a cabinet, you would be measuring square and being very precise. If my header's a little high, all I'm going to do is pull those 2 screws and drop it down 1/4 inch to make it line up with the door. If the door wasn't parallel here, then I would have to move the screw position in relation to the back of the hinge, one way or the other. And you can fashion yourself a handle of any sort. We could just put a screw in here. You also need maybe a latch. There's a handle, and then a string or a piece of wire. This is quick and dirty. Obviously, there's more sophisticated methods. That's really quick. I just thought of that. All right. So now I think we were ready for plastic, eh? We've got 2 more pieces that we'll put in here. We'll avoid putting our cross string, but feel free to do that. That'll further add structure. I think you get the idea. Let's put them back here. A little bit long. That's good. That will hold. Oh yeah. From before. Sorry. That's right. Oh.
You want to get through the door?
No, look, we left the screw.
Oh, okay.
Trailer. So some places I put 1 screw. Feel free to put 2, just to secure things. I've got 1 inch on the bottom of the door there, just so it clears the grass and everything. We've just lapped the door frame on top of one another, so it made a space in between the top of the door. That could be crucial in winter time. It would be letting heat out quickly. So ideally I'd put another piece here on the jamb and on the door so that those pinched quite close. You could further weather stripping to make a more airtight seal. We know that the overall length of the PVC pipe is 18 feet. So we'll roll out a piece that's maybe 2 feet on either side, so 22 feet. One foot of extra on each end.
I better do that again. Because I was measuring out 22.
The roll is 59 feet. And what'd you buy that for? 40 bucks?
No, that was only 22 with tax.
22 for the 4 mil. So you'll see the quality of the plastic as it goes on.
If you do it on a cross angle like this, you'll be pulling it over the ribs. If you pull it straight down, you'll get caught in the ribs.
Tricky to do this on a windy day.
Yeah.
You said this was 9 feet.
Maybe it's 102, Rob.
Pardon?
It might be 102, not quite 9 feet.
Well, yeah, it's 102.
Pull that tight right there. Yeah.
Yeah, it's not 102.
Yeah, that's okay. That's good. That's perfect.
Oh, so we got 6 inches extra.
Yeah.
Oh, okay.
So you can actually use that 3 inches on each side just to wrap around and then put a piece of tape at the back.
Okay.
I'll cut you some pieces of tape.
What kind of tape you guys using?
Good question. And all the different types of tape here. So, yeah, this is just regular packing tape. This is Tyvek. They call it air barrier tape. If you see a home in construction that's white and it says Tyvek and Home Depot across it or whatever, this is what they'll tape those connections with, and it's quite a bit stickier. Probably wax my hand. Anyway, they've got it in the red or the white. The white is actually a few dollars extra, about $12 a roll. Packing tape's obviously like $1 a roll. This was some other reinforced. Yep. Thickness of the 6mm poly, it's a different size roll, but I'd have a bigger roll of it. And then there's also this foam gasket, which is called sill gasket for between the foundation and the framing on a house, but it's pretty cheap, so I thought you could probably put this, staple this between the door and the jamb, and it would probably provide a decent seal. I often just do a little corner fold over on that tape because it's so hard to find the edge. You get the idea in terms of adding the plastic. You would continue along the front and the door and using a standard staple gun. Rob has given you the idea to ventilate from the bottom through the door and potentially even add a hatch at the top. So that's going to be the basic functionality of your greenhouse. Is there anything else, Rob, that you could suggest that people might want to do?
No, I think that
Thicker plastic, maybe?
thicker plastic probably, and or double it.
Double it, yeah.
So that you don't get the dripping inside.
And if you want to build something stronger with more longevity, you could go with 3/4 inch PVC plastic and 2x4 lumber. You know, the stronger lumber is going to last longer, and your cross members could be also lumber. But that's it. Thanks for watching.